last one. So this angle will be equals to that angle. So now if you look at this, let's name the angle. Maybe we can say this is A, this is B, C. Then this side, let's call this DEF. DEF. Please pay attention, because what we are about to explain is very important for you to answer that question 9. Please make sure that you move with me, and then I'll definitely move with the movers. Please, since I'm gonna move with the movers, make sure that you don't you are not left behind. So what are you given? I need you to understand what you are given. So you'll be given 2 triangles. So I'm given that triangle ABC, triangle ABC, and we also given triangle DEF. Then you need to tell us what is given there. So on this two triangle, we can see that angle A is equals to angle D. This is given, and it is also given that angle B and angle E are equal. Look at the colors there. And the last one, we are given that angle C is equals to angle F. So if this is the case, hence we can conclude and say these 2 triangles, which is ABC and triangle DEF, they are similar. They are similar, and what will be the reason for that? So triangle DEF. Can someone please tell us the reason? Why are we saying that these 2 triangles are similar? Can someone please help me with that? What will be the reason for that?
I think the triangles are similar because of they have equal angles, so it will be angle, angle, angle.
Exactly, the reason is angle, angle, angle. Shay, thank you. I can also see your comment. So it's angle, angle, angle. Wow, that's very good. So now look at this, guys. Look at this. I need you to note something which is also important. So please, we're gonna use this as we move on the next. And this is a notice, guys. If you have 2 triangles that have 2 corresponding angles, let me say if you have 2 triangles. So if you have 2 triangles, so on the 2 triangles they have 2 corresponding, we're gonna say this is corresponding equal angles. So if this is the case, then therefore you can conclude and say that the third angles in each triangle are equal. Then you can conclude and say the third angle in each triangle are equal. So we're gonna come back to this so that you can understand what I'm trying to tell you on this one. So let me quickly give you an example so that you can know how this works. So now what I'm trying to say is that if I have 2 triangles, this is my first triangle, and then let's say that I have this as 40, and then this is 40 degrees, this is 80 degrees. Then we don't know what is that angle. That angle is unknown. Then we have another triangle that has 80 degrees, and then this is 40 degrees. So what I'm about to explain is very important, because sometimes in an exam you might find an issue like this and you'll be like, no, what should I do? This angle is equal to that angle. We can see that, and then now it's also given this angle to be equal to that angle. So this tells you that if this is the case, you can just conclude and say these 2 angles are equal. Why? Sum of angles in a triangle. So this tells us that the missing angle, to find the missing angle, we'll say this is 180 degrees minus the sum of 40 plus 80. So when you punch that on the calculator, this should give you the third angle to be equal to 60 degrees. So this will be 60, this other angle also will be 60. I hope you guys understand that. So I just need a confirmation, then we'll move to examples. 100%. So now when let's work on examples, guys. I want us to start with examples. So let me quickly draw a circle here, then we'll try to answer the following questions. Okay, so let's say this is my circle, then I'll have a line from this will be B, and then this is C. Let's say from there we also have a line. Okay, let me redraw this. Okay, I just want to put it, my circle, this side. So if this is C there, and we put B somewhere here, so we have a line from C to B, and then let's put A here so that we can draw another line from A to B. Maybe we can also put E there and draw another line from A to E. We have F here, let's put F, then we're gonna draw a line from A to F and another line from E to F. Then let's call, maybe we should leave it like this, or we should move a line from C to what? From C to E. So let's name everything on that triangle. Let's give this circle some angles. Né? So first thing first, I'm gonna call this point here M. Guys, please note that this is not drawn to scale. Né? Just note that this is not drawn to scale. But I think I can fix this so that this can make more sense. Né? Let me try to fix this. Let me remove this line here. I see there's someone requesting. Okay, guys, I just want to fix this. Né? Maybe also remove this, also this line, eh? Because I think it's best if we move the point E somewhere here, because if it's there I can draw a line from this to E, then another line from E, and then like this, eh? Okay. Now guys, I see other learners are requesting. You know my issue, guys, is to separate the groups. We were not supposed to group you in 50 learners. We were supposed to just make like one group. So I'm not sure if that was gonna work if we have more than 100 learners in one lesson. I'm not sure if that was gonna work, Owen. So I'm not sure how, but Emily, so you also got a link?
Yes, I got the link.
Well, we are doing what I did with you during the day. Maybe I don't know, maybe if you stay in on the lesson you learn something new. I'm not sure if we'll get time to do other examples, but it's fine, you can join in there if you want. But if you did understand the work that we did yesterday, you are more than welcome to exit the lesson. Eh?
Okay,
the one that we did during the day, you are more than welcome to leave and work on something different. Eh?
Okay, sir. I'll just leave. Bye.
Sharp. Have a great evening.
Okay, bye.
Okay, so now I can call this point here, I want to call this M, which will be the center of the circle, and this is 2, this is 1. So I'm just naming my angles. This is 1, this is A2. Come on guys, there are still learners requesting to join now. Right, so now, and then this is E1, this is E2. Okay, so this is the only information that we have, but I'm just gonna give you guys something very important here. Né? So remember, this is not drawn to scale, but the most important thing on the statement is that AME, it's a diameter, okay? It's a diameter, right? We'll come to that, and then width, it's a diameter with center M, with center M. So now the diameter, this diameter, it is given that it bisects the angle FAB. We'll come back to that. Now let's look at the question. The first question, we need to prove that the triangle AEF, it's similar to what? To triangle AMD. Ladies and gents, I have something very good for you today. Please make sure that you sit in, pay attention, and enjoy the lesson, because we're going to have so much fun. I'm already enjoying this. By looking at the question, the proof that they want us to do, already I'm having so much fun. So hopefully you'll also have the same enjoyment that I'm currently having when I explain this to you. So guys, when you prove that two triangles are similar, first thing first, I need you to go to that triangle and highlight those two triangles, AEF. So I'll start from A, I'll move to what? To E, and then I'll move to F. So this is the triangle this is the first triangle that they are referring to. You need to make sure that you highlight that triangle. Then I'll go and also do the same for triangle AMD. So I forgot to mention that this here is D. You see this one here, this is your D. And then this will be D1, 2, 3, and 4. Okay, so now we need to draw another triangle, which is what? Another triangle which will be AMD. So we'll start at A, we'll move to D, also to, it's AMD. So this is the triangle that they are referring to. I hope you guys understand how I got these two triangles. Can you see my triangles? That's very important to know the triangles that you have to work on. So those are the two triangles, 100%. Okay, so now on these two triangles, then you just have to find the angles that are equal. I'm not sure if you guys want us to give you chance to give me angles that are equal, or okay, remember we are here to learn. Let me not have my enjoyment alone. So I'm gonna give you chance to join me. I'm giving you an invitation. Please come to this party. Let's have some fun. Can you please tell me, just raise your hand and tell me which angles are equal between these two triangles. That's the invitation I'm giving you. Join the party. Let's have some fun. Let me hear what you guys have to say. Moepiani, I'm listening. You raised your hand, you removed your hand. What's going on? I'm listening.
Hello, sir.
I'm listening. Do you have something to say?
you were
Guys, give me a
told
second. Let me
that
just connect my speaker so I can hear your voice clearly. Even when I'll know that, no man, I know this voice from somewhere. I'm listening, Kurapit.
sir, we were told that AME is a diameter. Therefore, we can conclude that angle F is 90 degrees.
Okay, can you please pause there for me? You are saying that angle F is 90 degrees. Can you please tell me what is your reason? Why are you saying that angle F is 90 degrees?
So I'm trying to remember the reason, but let me check.
So the reason is angles in what? Same segment, or can we say semicircle? It's semicircle, ne?
Yes, angle in a semicircle.
Or
So
we can
yes,
say
sir.
angle subtended by a diameter. Okay, I'm listening now. Now you have my
Yes, sir.
attention.
Which is also equal to angle D1. The one
Okay,
that we were
so
given is 90 degrees.
exactly. Angle D1 is 90. The reason for this one is given. Therefore, tell me, Kurapits, can we conclude and say angle F is equals to angle D1?
Yes, sir.
Okay, 100%. So, uh, okay, so this one, it was given, the first one. So now, Kurapits, thank you very much for that. Now, can someone please tell us other two triangles that are equal? Kimango. Who's this? Let's see, we have Katleho.
Sir,
Yeah, you raised a hand.
sir, on the first statement, sir, you gave us that AME is a diameter and it bisects angle FAB.
Katleho, thank you very much. That's very brilliant. But now tell me, if it bisect AD, what can you say about that? Please say that
It,
again.
sir, you gave us that AME is a diameter and it bisects angle A.
Exactly, guys. Can you see where it's Katlego going with this? Katlego is saying that the diameter, it bisect angle A. Right. Let's explain the meaning of bisect. When we say the angles bisect, this is saying that it's like saying when we say the angles bisect. So this is when we say they bisect. It's like saying that equal in equal. It cuts this angle in equal. So this angle A1 is equal to angle A2. Thank you very much for that. Ne? So we're gonna say that angle A1, which is in triangle ADM, so angle A1 is equals to angle A2. And the reason for that is that Katleho said AM bisect. It bisect that angle FAB. So now maybe there's someone who don't understand how to find the angle AB. Guys, when you are given something like this, né, and you need to understand which angle are they referring to, you're gonna start from F, you move to A. You start from F, you move to A like this, and then you move from A to B. So the angle that is between that line is the angle that they are referring to. I hope that makes sense. Okay, so now from this, what I'm gonna do, I need to find other angles that are equal. So now, please, no need for you to stress, because I don't think we can give more reasons that we can conclude and say this angle here, which is E1, is equal to that angle. Remember what I just showed you guys now. Where is it? Oh, this is our note. Remember what I just showed you. If two angles are equal in each triangle, then we can conclude and say that the third angle is also equal. The third angles are also equal. Therefore, we can just conclude and say angle E1 and angle M1 are equal. So we can conclude and say angle E1, it's equals to angle what? Angle M1, third angle of a triangle. I hope you guys are happy with that. So we're gonna say this is angle E1 and M1. These two are equal. Reason, it will be the third angle of a triangle. So now we can conclude and say these two triangles, the triangle AEF EF. It's similar to what? It's similar to triangle AMD. It's similar to triangle AMD, and please give them a reason: angle, 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 or you can say angle, angle, angle. That's the reason you need to give them. And that's it for the first question. Let's move to the next question now. So now, the next question, in most cases, or let's say they use their hands. They might say, number B, hands find the numeric value. Hence find the numerical value. Hence find the numerical value of, let's say, AF over AD. Right. What is the numerical value? Okay, I forgot to indicate the mark allocation. This one is 5 marks, and this one is also 5 marks. So if I send you an invitation and I say join the party, if you were not interested, now I believe by looking at the mark allocation, you are very interested to join the party. Now, so now look at this. If they want the numerical value, this has to do with proportionality, ladies and gents. Proportionality. When you see something where we are dividing, this is the ratio. So to do this, guys, please, look at what I'm going to do here. If you get lost, please make sure that you stop me so that I can explain this to you now. So I'm just gonna find the perfect color. Okay, I think we're just gonna go with, because I need a very strong color. Can someone please tell us which color should we use? Which one is strong? I don't know. We need a strong color so that you can see what I'm going to do. Maybe a pink one. I don't know. Pink is not strong, but it's fine. We'll take it now. So look at this. First thing first, they said AF and AD. So look at this. Where it's AF, this is my line AF. And I think you guys can see that one. AF. And where is your AD? This is my AD. Guys, you don't have to stress about this. If you look at this, can you see that this AF and AD, they are on the triangles that we just proved that they are similar. I hope you guys understand that. So what I need you to do, I need you to redraw your triangle somewhere, and you'll understand why we are redrawing the triangles here. Now, so this is my M1, and this is 90 degrees. This is D, and this will be my A1. I hope you guys understand how I remove that one. Then the next one, it will look like this. Right. And this will be my E1, and this is my F there, and this will be my A2. So let's go back to what we currently did, because they said hands means hands. Use the proof that you just did. We just proved that this angle is equal to that angle, because that diameter bisect the angle, and we just proved that this angle is also 90. So this angle is equal to that angle. Please pay attention to what I'm currently doing now, because this is very important. If you get lost, it will be very hard for you to understand the proportionality. So look at what we have now. So now, what I'm gonna do is that I'm gonna say that we are looking for AF. So I'll move from A to F. Look at this. I moved from the green angle to what? The green angle to the blue one, which is my AF. I'm gonna write that down and say, to answer number B, we are still on number B. So to answer number B, AF over, if it's from green to blue, even this side, it should be from what? Even this side, it should be from green 1 to blue. Then it will be AD. we're gonna equate this to EF. Let's say I move from E to F. You see, if I move from E to F, I'm gonna write this down and say this is EF over, I move from the red angle to the blue one. Even this side, I should move from the red to the blue one, which is MD. So this will be MD. I'm going to equate these two. Then I can move from AE, which is green to red. Even this side, I should move from green to red. So AE over AM. Right. So this is the proportionality. In order for you to use this, first prove that these two triangles are what? These two triangles are similar. Are you all happy with that? How we created our proportionality? Is everybody happy with that? Thank you very much. Okay, so now from this, guys, from this, I'm not sure how are you going to figure this out when you are in an exam, but let's try to find a way. Let's try to find a way. So now I think it's best if we focus on, look at this now. We need to eliminate something, because when they say the numerical value, our answer should be 3, our answer should be 50, our answer should be 16. We don't need F. So this tells you that we need to equate two fractions here. We need to equate two of them, but to know that which one you're gonna equate, you need to be very careful about that one. So look at this. We need to choose which one are we going to equate. Obviously, we need AF over AD. This one is in. So we need to choose between these two. This is how you choose. When you choose this, we need to check if we have a line that is equals to EF, or if we have a line that is equals to MD, we have a line that is equals to AE or AM. We need to check if between these four lines, are there any lines that are equal? I need you to look at the diagram and check if you have any other lines that are equal. And this is my diagram. I'm not going to waste time and ask you which lines are equal. I'm just going to go straight to the point and tell you that AD, okay, let's not use that one. Let's not use that one. Which one should we use? Let's look at the line AM. So AM is equals to ME. Can someone tell me the reason why are those two lines equal? Anyone?
They are equal because they have equal radii.
Thank you. Those are radius, guys. The line from AM is a radius and ME is also radius. So I can just put it down here and say AM it's equals to ME. And the reason for that, radii. So now after you find the two lines that are equal, you're gonna check on your proportionality. Where's AM? This is my AM. And where is ME? Look at this. Where is ME? Guys, do we have ME here? Okay, so now, okay, it's fine. So now after choosing which, look at this, guys, are you still with me now? After choosing which lines are equal, so AM is equal to ME. You can see that on this one, we don't have this. So we need to choose the proportionality that has AM. So this one is out. We need to equate what? We need to equate AF over AD with what? With AE over AM. So the only thing that you need to do is to prove that this guy is equals to AE. That's what you need to do. But let me take this step by step now. Let me take this step by step so that you guys can see what is going on here. So we just said AM and ME are equal. Okay, so now if they are equal, this tells you that, guys, I can find what? I need to calculate what is AE. What is AE equals to? The length of AE. Look at this. I have the length from A to E, and then this is AME. I'm just going to put it down here. This is AME. And we are saying that these two lines are equal. Is that they are equal. Therefore, if they are equal, we can say that AE, I can say this is AM. What can I say? I can say this is AM. This is also AM. Since they are equal, instead of calling this ME, I can call this AM because they are equal. So what is AE equals to? It's AM plus AM. So AE will be AM plus AM. Therefore, the length of AE is just 2 AM. I hope you guys understand. So where there's AE on the fraction, you can write 2 AM because the reason is to eliminate 1, so that we can get a numeric value. So this will be AD is equals to AE is 2 AM over what? Over AM. Look at this. These two cancels. This is just 2. Therefore, the numerical value of that AF over AD is equal to 2. We just need a number. So you just have to find a way to get rid of one of those two. But when you look at this, you can see that, oh, AM and ME are equal. So now, since they are equal, I can find AE by adding the 2. You understand? Why did we choose AM? Because that's what we have on our fraction. So we can get rid of that AM. I'm not sure if this makes sense. Do you guys understand what happened here? Okay, 100%. I'll just move to the next question. The next question, we're still using the same diagram. The next question, let's prove that triangle CDB, it's similar to triangle ADE. That's the first question. The second one, we need to prove that AD squared, it's equals to CD times DE. So now this will be 4 marks and this will be 3 marks. We are using the same diagram. So I think it's best if we bring the diagram down here. Okay. Let's bring down the diagram. See, guys, this is CB. Okay, then we have E here. Draw a line from this, then we're gonna have this here. This was A, then let's put F here. So now this is what we have. We are still using the same one, and then we need to do the following proofs. So we can say this is from, yeah, and then this was 90 there. Guys, I'm very sorry if you don't see the diagram there. 2. I'm just gonna indicate the angles that are equal using the different markers. So we said that angle A and that one are equal. Those two angles are equal, or maybe we should also name those two. Maybe we should also name them now and say this is angle A1 and this was angle A2. I'm very sorry now. And then this angle here. Okay, I don't think we're gonna need those angles. We're gonna need to indicate that those angles are equal. I don't think so now. 1, 2, 3, 4. Guys, I think we can do better than this. This is not the best we can do, but we can draw a nice triangle, even though we are running out of time. But it's very important that you learn how to answer these two questions. The first one, already I've showed you guys how to do the first one. But what about the second one? What about number B? Because if you can look at your past paper, the one that I just sent now on the group, you can see that is there on the question paper, the previous past paper. Okay. This is B, C. I know that somewhere here it will be F. This is A, and this is E. A line from A to E, a line from A to B, and then this is my center. Okay, this is even much better. And then a line from C to what? A line from maybe C should come somewhere here. A line from C to E. Much better. Then I'm gonna put a line from C to B. Next time I'll just have the drawing on the board, don't worry, just to save time. So this is A1 and A2, then this is E1, E2, A1, A2 and A1, then this is 1, 2, 3, 4. Let's look at this diagram, guys. Let's look at what they want us to prove. So they say that CDB, remember you need to highlight C, this was D, C, D, B. So now you can see which triangle we need to focus on. The blue one, this is what we need to focus on. Then you go to another one, which is ADE. So ADE. So the other one is this one. I hope you guys can see that. I'm very sorry about the drawing, but now I think you see which triangle we need to prove that they are similar. So I'm not sure, guys, do you want to join the party and give me the angles that are equal? Anyone between these two, what is this? Between these two triangles, which angles are equal?
C1
I think
equals
so.
C1 equals A2, angles in same segments.
C1 is equal to A2.
Yeah, angles in the same segment.
Okay, I'm just gonna write that angle C is equals to angle A2. Let me explain how this learner got that. Remember this arc AE. So if we look at the arc, the angle that is opposite to that arc is A2, and then the other angle that is opposite to that arc is angle C. So you can see that angles subtended by the same arc will be equal. So now, can someone tell us the other angles that are equal?
The other angle that is equal is angle E2 and angle B, also angles in the same segment.
Exactly. Angles in same segment. And then the other one, it will be angle B. This angle B is equals to, I've never heard Shay say something. Shay, I don't know your name. I'm sorry, I don't know your voice. I'm not even sure if I'm saying your name right, but I don't remember you saying something in the lesson. What's wrong? Are you still in the lesson?
No, don't worry, sir. I'm speaking in the chat.
Oh, okay. I know you guys. I can even hear your voice. Some of you have already, I already know your voice there. So yeah. So guys, when I have it like this, now remember we said we can conclude that the other third angle are equal, but there's no need for that because look at this. This angle will be equal to this whole angle. vertical opposite angle. So we can say that angle D4 is equals to the sum of what? It's equals to the sum of D1 plus D2. Remember this whole angle, it is in what? It is in triangle ADE. It is in triangle ADE. Right. So now, when it's like this, what will be the reason? Vertical opposite angles. Right? So, that's the reason. Therefore, we can conclude and say that, therefore, the two triangles, triangle CDB, it's similar to what? It's similar to triangle ADE. So they are similar. Then you'll definitely get your 4 marks. I'm only interested in that number B. Prove that AD is equal to CD times DE. But when you have something like this, I need you to go and first draw the line CD. You're going to draw a line from C to D. You're going to put that line like that, and then draw another line from D to E. So another line from D to E, that's the line, and then draw a line from AD. Look at this. So you'll find something like this, then close it. You'll see that this is the triangle that they are talking about. So this is the triangle they're talking about, this one. Right. So now, for the fact that I have AD squared, I'll find the length that is equals to AD, because we need to, okay, let me go back, because if you miss this information, I don't think or you'll be able to solve this problem when you get it in an exam. So I'm just gonna go back and make sure that I explain this. First thing first, we said we draw a line from C to D. We definitely did that. And then we need to draw another line from what? DE. We did that. Then we need a line from AD. We have that line from AD. So if you can check, you need to have 4 lines. 4 lines. So that you can create 2 triangles. 4 lines equals to 2 triangles. So all of this line, they should form a V like this, so that you can close them and have your triangles. So now, since I have this AD squared, so this tells you that this is like AD times AD. We need to find another line that is equal to AD. And that line is what? That line is DB. I'll explain why they are equal. The reason I'm saying they are equal is because of that line drawn from center M. It bisects the chord. So this is equals to that. I hope you guys can see that. Can you guys see that? AD is equals to DB. Reason the line drawn from center bisect the chord. So if I have a center like this, and then I have a chord, the line drawn from center bisect the chord. So this is what I'm trying to show you. So now that you have this, I need you to make sure that you close your triangles. Then you'll have 2 triangles. So we set this, you can see this is the V. I'm gonna close that triangle like this, and this is also the V. I'm gonna close that triangle. So you can see that the triangle that we need to work on, most of the time it will be the one that you already proved that they are similar. But if you did not show this, you're gonna get a lot of marks. It should be 7 marks, 8 marks. But in most cases, the first one to prove, then now we need to do whatever that we got, and then we can just work on this. Now, so since we proved that triangle CDB is similar to triangle ADE, we can use the proportionality. Now, so look at this. I'm gonna redraw my triangles and try to work on them. Let's redraw. So I have the first triangle here, which is CBD, and another one which moves like this. This is EAD. I think everyone can see that. These are the 2 triangles that we proved, and we said that angle A2 and angle C are equal. So I'm just going to highlight that. Angle C and this angle A2, they are equal. Then we also proved that this angle D and that angle D are equal vertical opposite angles. Right. Then we also proved that this angle and that angle are equal. So now we can do the proportionality. Guys, when you do the proportionality, I need you to refer to the question that we are proving. We are proving that AD squared is equal to CD times DE. We are proving that AD squared is equal to CD times DE. So let's work on that. First thing first, we start with what? We can start with CD. Let's create CD. So I need to move from C to D. So I moved from the green angle, which will be CD, over, I moved from green to blue. Even in this other triangle, I need to move from green to blue. So this will give me AD. So this will be over AD. Then it's equals to, I need DE on my proportionality. From D to E, it's blue to pink. So I'm going to say this is, look at this, guys, please. This is another mistake that you can make in an exam. Look at this. DE, it comes on your denominator. Why? Because remember, we put CD on numerator, which is from this triangle. So this triangle always on top and this triangle always on bottom. Right, please make sure that you pay attention. So we move from a blue angle to the pink one to form that DE. Even this side, we need to move from blue to pink to form DB, 100%. So now when I have it like this, when I have it like this, I need to cross multiply. This will be CD times DE. It's equals to AD times DB. Look at this. We already have what we are looking for, but there's something missing, and we'll definitely work on that. We already have CD times DE, then we have CD times DE. So the reason for this, you need to give them a reason why you are creating that proportionality. The reason is that we have similar triangles, and then now we need to prove that DB, it's AB, it's AD, so that when we multiply AD and AD, we get that AD squared. So we just have to find a way to prove that DB, we need to prove that AD is equals to DB. Let's go to the diagram to find a reason why AD and DB are equal. You don't have to go far. You know that AD, it should be equals to DB, so that where there's DB, we substitute AD. You just have to go and look for a reason. So I need AD, which is this line here. I can mess this up because this is injury time. We are left with 5 minutes in this lesson, so I'm just gonna mess the drawing now. So AD is that line. It's equals to DB. The reason that they are equal is that the line drawn from center bisect the chord. So you can see that we said this line and that line are equal. We already talked about that. So the line drawn from center bisect the chord. So we can say that MD is perpendicular to what? To AM. Or you can say line drawn from center. Bisect the chord. I hope you guys understand. So when you have it like this, you can just go back and substitute and say on this equation I have C times D, which is DE. It's equals to AD times AD. Since they are equal, therefore AD and AD is just AD squared, and this is equal to CD times DE, and that's it. When you have it like this, you'll definitely collect all that marks. And this is it for the lesson. Guys, let me quickly open that question paper now. Let me quickly open that question paper so that I can remind you the importance. Why did you join this lesson? I don't remember which question paper is it, but let me just check this one. Okay, let's look at the question so that you guys can remember why you joined this now. So question 8 is grade 11. You just have to find angles that are equal. Then if you look at this question 9, apply everything that we did, calculate the size of what with reasons. Then question 10, so if you understand everything that we did today, I guess you understand 60% of Euclidean geometry. The only thing left is for me, guys, to teach you how the area works. When you have to prove something using the area, or to calculate the area, the proportionality of area, and so on. Look at the questions on this one. For 6 marks, prove that US is a tangent, for 4 marks, prove that SPU is similar to SUW, and then prove that, you see, this one, 10.3, you already know what you need to do, and this is 2 marks. I'm not happy with the 2 marks, but even though, look at this, 10.4, it is still same question. So if you understand what we did today, I believe that you almost there, guys. 60% of the work covered. So on our next lesson, I think we're gonna wrap this Euclidean geometry so that we can start with analytical geometry, because the Ntombi Zodwa requested me to work on circle geometry. What is this? Circle geometry, analytical geometry, where you have you see this one, the circle one. I hope you guys will get much time to cover that. So based on what we did today, you guys have any questions?
Sir,
Mpo.
where can we get this recording? I really need it.
Okay, guys, about the recording now, let me quickly stop the recording now.